This is your guide to finding the nth term of basic quadratic sequences. Unlike linear sequences, quadratic sequences don't increase or decrease by the exact same amount each time. So here, if you notice, the sequence is increasing by a different amount each time. However, what you might notice that the amount that the difference is increasing by each time is the same. So this is increasing by 2 each time. This is known as the second difference. So the difference of the differences of each of the terms. If this number is the same each time, then you have got a quadratic sequence. Now, a quadratic sequence has the following property, that it is linked with n squared. So in other words, linked with the squared numbers. So just like with a linear sequence, we actually write down underneath the squared numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Now if you notice, each of the numbers that we've written down here is linked quite closely with the numbers in the sequence. In fact, each of the numbers in the sequence is just one more than the related squared number. So we can say that the sequence is n squared, the squared numbers, plus 1. And this is our nth term. Same for the second example. So firstly, without knowing that this is a quadratic sequence, we have to just check. So here, it's gone up by 3, by 5, by 7, and by 9. So again, we've got this property that the second difference, the difference between these differences, is 2 each time. Therefore, a quadratic sequence. So again, the very first thing we write down underneath the sequence is the squared numbers, which we represent using n squared. So here, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So again, we're looking for a link between the squared numbers and the numbers in the sequence. And if you notice this time, each time we've got to take 2 away to go from the squared number to get to the number above. So we say that the nth term for this sequence is n squared. Take away 2. For this sequence, same idea again. So here, from 4 to 16, it's gone up by 12. From 16 to 36, it's gone up by 20. Then by 28. And by 36. So obviously these are not increasing by the same amount each time. So we see if the second difference is the same. That's an increase of 8. From 20 to 28 is 8. And 28 up to 36 is also 8. Therefore, we have a squared, or linked to the squared numbers, so a quadratic sequence. So the first thing I write down underneath is n squared. This step is going to be the same every time. These numbers will always be the first few squared numbers. And we then need to try and see if we can see a link between these squared numbers and the ones above. Well, each time it's not adding something this time. Actually, we're multiplying by 4. 1 times 4 is 4. 4 times 4 is 16. 9 times 4 is 36, and so on. So we want 4 lots of the squared numbers. So our nth term is actually 4 n squared.